Hello, 8th grade. Today we're going to continue working with exponents, but just sort of stepping it up a little bit. We're going to be talking about multiplication with exponents. So as you're viewing this presentation, you have two options. You can have your notebook open and taking notes there, or you could have the slides open that I shared with you, and you could be typing your notes onto the slides. So the title for today would be multiplication with exponents. So we're going to take what you've already learned about exponents and apply it to multiplication. So let's start with this idea of 7 squared. Now, when I said squared, it's the second power, means the same thing, right? When we square a number, we're raising it to the second power. When we cube a number, we're raising it to the third power. Now, I want you to think about what that means. And this may be somewhat simple to start, but that understanding is going to be really important as we go forward. 7 to the second power means that 7 is a repeated factor twice. So it means 7 times 7. And 7 cubed means 7 is a factor and it's repeated 3 times. So now what happens if we took those two quantities, 7 squared and 7 cubed, and multiplied them together? Well, think about what that means. We said 7 squared means 7 times 7. And we said 7 cubed means 7 times 7 times 7. So what is it that we have? And now I'm not asking you to actually find the product. I'm asking you to simplify this expression. So 7 squared times 7 cubed. Now you can see we have 7 repeated as a factor 5 times. So we would write it as 7 to the 5th power. That would be the simplified version of that multiplication problem or that expression. So what did we just do? Well, say we had the expression 2 to the 3rd power times 2 to the 4th power. Now you might notice that both of those factors have 2 as a base. So what does it mean? It means that we're doing 2 times 2 times 2 for 2 to the 3rd power, and we're multiplying that times 2 times 2 times 2 times 2, which is the same as 2 to the 4th power. So these first 3 2's represent 2 to the 3rd power. The next 4 2's represent 2 to the 4th power. And so all together, you can see that we did 2 to the 3rd power and then 2 to the 4th power gives us a total of 2 to the 7th power, because there are 7 2's that are being repeated as factors. So let's say we had a to the m power. Now what does that mean? It means some unknown raised to another unknown variable, power. But again, a is the base, and we multiplied it times, again, an exponent that had a as a base with some other unknown exponent. What would we do? Well, we would keep the base of a because it's common to both, but we would add the exponents. Because isn't that what we did in the first problem? We took 2 and added 3 plus 4 to get 2 to the 7th power. Now, we don't know what m and n are, but that's okay. So let's try these. I'd like you to pause the video and work out simplifying these expressions, and then come back and check your work. Oops, I changed the screen inadvertently. Okay, sorry for that little blip in the video there, but here we go. So 3 times 3 to the 3rd power. So 3 by itself means 3 is just a factor once. So if you multiply that times 3 more 3's, that would give you a total of 4 3's. So we write that as 3 to the 4th power. 2 cubed times 2 squared times 2 cubed. We did this problem, 2 to the 5th power. m to the 5th power times m to the 7th power. Now, m is the common factor, so we keep that base of m, and then we add the 5 and 7 to get 12. Now, on this last one, you'll notice that there's two different bases, but we can only multiply them if they are the same base. So x squared times x cubed can be done to give you x to the 5th power, and y times y to the 4th power can be multiplied. But then we have to keep them multiplied times each other. Now you notice I did not put a dot, and I don't have to. You can if you want, but if you just put them side by side, that indicates multiplication anyway. Okay, so now these problems are a little bit different in that they have what we call a coefficient. So a coefficient is the number in front of the variable. So in this case, -2 is a coefficient. It's -2 times x squared, and 3 is a coefficient, and it's 3 times x to the 5th. So what we're going to do is we're going to expand this problem out, and then we're going to rearrange it so that we can simplify it. Okay, so go ahead and write that first problem, -2x squared times 3x to the 5th. We're going to write it in expanded form. So what we have is, let me try that again. What we have is -2 times, and I'm going to put it in parentheses because it's a negative. Remember, we talked about that last week. X times x again, because x squared means x times x. And again, I'm not going to use a dot here. You can, but you don't have to. And then we're also multiplying that times 3. And I'm going to put it in parentheses just because it's in the middle of all this other stuff. And then we have x repeated 5 times. Whoa. Okay, so now what we want to do is we want to multiply all the things that have the same base, right? X is the same base, and we have how many x's? Well, we have 2 of them here, 5 of them here, so that makes x to the 7th power. What else do we have? Well, we have -2 times 3, which we can multiply, so we would multiply them to get -6. So this first problem, if we were to multiply the coefficients, multiply the powers that have the same base, we could rewrite it as -6 times x to the 7th power. Okay, so given that example, I want you to try numbers 2, 3, and 4. Go ahead and pause the video so that you can complete those problems. All right, let's see how you did. So in number 2, you can multiply the 6 and the 3, the coefficients, to get 18. A to the 3rd times a is a to the 4th. 18 a to the 4th power is how we would write that. You could also read it as 18 times a to the 4th power. That would be fine too. All right, number 3, you multiply the coefficients of -5 and -3 to get +15. C squared times c to the 7th, c to the 9th. And then on the last one, it's written a little bit differently, but the concept is still the same. You read this problem as 4x squared times 3x to the 4th. So you multiply the coefficients to get 12, and then you multiply the x's to get x to the 6th power. How'd you do? I'm having trouble pausing the video. Here we go. Okay, there's one last kind of problem we need to look at. And let's say we had this, we needed to simplify 36 times 2 to the 4th power. Well, you might notice that 2 to the 4th power is the only power in this problem. And we can't combine a number with a power. So we need to do something with this 36. Well, hopefully you might recognize that 36 is can be made other ways. So let's think about the number 36. And if you remember back in 6th grade when we would do prime factorization, we might think of this as 4 times 9, right? 4 and 9. But you know what? You might notice that 4 and 9 are both perfect squares. 2 times 2 is 4, and 3 times 3 is 9. So we could think of 36 as 2 squared times 3 squared. So if we were to replace 36 with 2 squared times 3 squared, then we would multiply that times 2 to the 4th power. And we could then multiply the two powers that have the same base. 2 to the 2nd power times 2 to the 4th power would be 2 to the 6th power. And now we're going to leave the 3 squared alone because it has a different base. So that's a way to simplify when you have a whole quantity, is to try to make it express it in terms of a square or another power, and then multiply. Okay, so now that you've watched this video, you always have the opportunity to go back and watch it again if you feel like you need some more help. There are only a couple of problems on today's problem set, but you do have some IXL also that you can use to help you practice this skill. Okay, I will see you later.